Chapter 2: Data Models and Query Languages. The chapter started talking about relational database, something like MySQL and Postgres, and that's the most or the widely used data model right now. Then it discussed the criticism that it faced because how developers used to find it a little bit difficult to handle the differences between the query languages and the object-oriented languages, which is the impedance mismatch. So yeah, there is a data type mismatch between the query languages like SQL, which supports char, varchar, numeric, and the programming languages like Java, for example. So to handle such mismatch, you would usually uh, use something like Hibernate object relational mapping tool. Uh, Maybe that's not that difficult today, but back then it was a little bit of a headache. So yeah, that was a reason. Another reason was that relational database is actually it's a strict or write on schema. So for example, if we have if our item has first name and second name, and now I want it to be just full, and I want it to be full name, so I cannot easily change the type of my item. It's not that easy to change it. Whereas in the document based model that we are going to discuss later, we can just add different types and it would be just fine, and we can just handle this on the application side, or like code, not the database. Okay, so yeah, and because of this of these two problems, we wanted a solution. That solution was the document based model. Just to mention, we have two different types of data models. We have relational and non-relational. Relational models, which we just mentioned, tables, rows and columns, and non-relations, JSON based, document based, or trees, which are the different data models that we are going to discuss later. Okay, the document based model is just JSON typed, like MongoDB, the most used one, which is usually good with one-to-many relationships and one-to-one. Okay, then it mentioned the many-to-many relationships. When and why do we need them? And to know that, it actually mentioned this example. So in here we have a LinkedIn profile where we have the, I don't know, some details, summary, experience, blah blah, and we just will focus now on the region. So yeah, we have the users table and we have the region ID, and we are using the region ID to reference the user is region in the regions table. Okay, so we are using foreign keys. And okay, so in here it mentioned, or it asked a question: which is better, letting the user enter his or her uh, region as a text input, or selecting it from a drop down? Okay, the answer usually would be the drop down. Why? Because of a lot of reasons. First, consistent spelling. If for some reason you cared about or wanted to search about this specific region in the future, or all the users that have this region, it would be much easier for you to search about it, because now you know we are 100% sure that this region is written in that way in our whole database. Uh, Second thing is handler localization. If your application has many or different languages, then of course it would be much easier to have a separate table, because then we can just add the localization much easier. But if it's just a static text, then we are cooked, or actually cannot handle its localization. Okay, then it mentioned another example as well, which is the recommendation example. Now, if my name is Jordan and I recommended Ahmed on LinkedIn, so now I have my now. Okay, so there are two scenarios. First, I'm going to use many to many or many to one relationships, or I'm just going to use duplicate the data or list it inside the user that was recommended, just like that. Okay, so for the second or latter case, uh, here is my recommendation, here is my name, and here's my image. If for some reason Jordan changed his name or his image, then now we would have inconsistency between the recommendation written on LinkedIn, like he would have different profile image between the recommendation and actually his real profile. So to handle this, there are two scenarios. First, okay, I'm fine with duplicating data, I'm fine with denormalizing data, and I'm okay with that, and I'm going to handle it inside my code. I will just, whenever there's an update, I will query through all these things and I will update it. So yeah, I know it and I'm fine about it. The other option which the book suggests is, okay, we actually should list the data in separate tables, and so we are making the update just in one place, and any change to that place would simply reflect in everywhere that cares about that type of data. So okay, so now just to be clear, we had relational database that handles many to many relationships. Then we were just so angry about how it was strict about its schema, and the headache of handling or the mapping between the query languages and our OOB languages. So we went to the document based, which is fine, and it's schemaless, and we can just put everything we want in our JSON files and it would be just fine. But then we had the problem of duplication and inconsistencies, and to solve it we actually need to use many to many relationships. But there was a problem that to actually normalizing this data requires many to one relationships or many to many relationships, which doesn't really fit into the document model, because document based models don't really support joins. Okay, I'm not sure about if they don't really support joins, maybe they do, but it's not as supported as in the relational models. I think also it would be much slower still if compared to the relational models. Okay, just to be clear. To handle this, you would usually make multiple queries to the database, and you would actually shift it from the query optimizer side, like using joins in the relational model, to handle it actually in your application code. Last I just mentioned that maybe you think that you don't really need this type of relationships, or you are fine with the document based, but that maybe it's usually that case at the initial versions of the applications, but usually things get a little bit complicated uh, on the run. Okay, so after mentioning the many to many relationships and the problem we had with the document based, we took a step back and it asked a question: are we repeating history? And then it mentioned the hierarchical model, which is a tree where each section or child has only one parent. Okay, before going to what was the problem of the hierarchical model and so on, I just want to mention something, that we have two type of query languages. Imperative and declarative. Imperative is when we have to uh, describe everything that we want step by step. Like for example, Java, it's imperative, uh, whereas relational database models, something like MySQL, it's declarative. You don't really describe step by step. You just describe or tell it what you want it to do. Okay, that being said, back to the hierarchical model. So, okay, the hierarchical model was like the document model. It worked well with one-to-many relationships, but it was not good with the many-to-many. It was difficult to handle, and it didn't support, again, joins. So developers had to decide whether to duplicate, denormalize data, or manually resolve references from one record to another. And to solve this problem, we had two solutions or two options introduced. The first was the relational model. Again, you'll go back to it. And the second one was the network model. So we'll start with the network model. The network model is simply same as the hierarchical model, but now we have the children. They have multiple parents, so that we can support the many to many relationships. Okay, so we just mentioned that the hierarchical model is imperative, uses imperative query language, same like the network model, and that's the main difference, or the main problem, is that we don't really use foreign keys. We use pointers, and we have to know the access path from a child to another. So that was very difficult to handle, and it was a headache to change anything in our data, because then you would have to go through a lot of code change, and yeah, it was so hard to handle. What was the solution for this? Back to the relational model. Again, the relational models introduced the foreign keys and having the data in separate tables, just referencing them. Also, it used declarative query language, so it's much simpler and easier to query. You really have to use pointers nor to care about knowing the access path or anything about that. Then it just made a small comparison between relational model and document model. It mentioned the advantages and disadvantages of the document model. So first, just briefly, the document model, its first limitation for sure is its poor support for support of joins. So yeah, document based doesn't really support joins. However, I think if you chose to go with the document model, then you wouldn't really have that much of many to many relationships, if you are lucky. So it wouldn't really be much of a problem. Or if it happened that you faced a case where you have actually many to many relationship, usually it would be simple, and in that case you would have to handle it from your application side to make multiple queries and so on, or and to duplicate, or maybe do duplicating the data. The second thing is that you cannot refer directly to an item in a document. You would need to actually access it like in its position, like the second item in this data or something like that. Then the advantages of the document model. As we mentioned, implicit schema, schema on read, schemaless, all mean the same things, is that we are moving the validation of the schema from the database to our application side. So yeah, there is a schema, it's not schemaless. However, we are handling this schema, so if there is a different data type for some reason entered, so as we mentioned in here, we have first name, second name. For some reason I decided to have full name. The database won't shout at me or anything, and I can just handle it from my side, in the application side. And that's what it is saying in here. The difference between the two approaches is particularly noticeable in situation when an application wants to change the format of its data. In a document database, you would just start writing new documents with the new fields and have code in the application which handles the case when all the documents are read, like in here. On the other hand, in a statically typed database, schema, which is the one we mentioned, write schema on write, for example, you would typically perform a migration. And that's the one of the reasons we mentioned at the very beginning. Then data locality. Usually if we are using document-based model, it's usually used for blogs, websites, or magazines, or things when we have huge articles that we actually want to load at once. So we don't really want to make multiple queries or joins to get that data. Also, we want it to load fast. So yeah, it mentioned that if your application often needs to access the entire document, for example, to render it on a web page, there is a performance advantage to this storage locality, because we really have to make multiple queries. So it would be much faster to handle it with the document base. However, if your documents if your objects are very huge and you are going to make updates on them, it's going to entirely replace them. So yeah, it would be so slow, just to mention. Graph model. So it mentioned in here that you shouldn't make your objects very huge if you are going to replace them at some point. Graph model. Usually, it didn't really talk that much about the graph model, so yeah. Graph model usually preferred in case of complex many-to-many relations. Okay, remember when the network, okay, so the graph model it's also a tree model, similar like the network model. It tried to solve the many-to-many relationship. So what's the difference between them? Okay, the main difference first, that the network model is imperative. We have to write step by step, we have to use pointers, we have to know the access path. Whereas graph model, it's declarative, so it's much easier and simpler to use. And the second reason is that we actually in the graph model we can use unique IDs to access specific items, whereas in the network model we have to traverse the tree to get to a specific item. um, and last, the network model is schema on write, so it is just the difference between the same difference between the relational that we mentioned and the document model, whereas the graph model, it's a schema on read, so it's more flexible to use. And that was actually chapter 2. I know it's very messy, but I tried to explain it or summarize it. So yeah, thanks for listening. Bye.